I want. Yeah, thank you. Okay. Phew. Well, there's no point actually, because I'm going to do the weight homework now, so you're going to write it down. So it doesn't matter, I suppose. Okay. So the first one for the weight. A skydiver jumps from a plane. He has a terminal velocity of 56. Approximately how long until he reaches his terminal velocity? Okay. Now, what you have here, he jumps from a plane, so this is him here, and you have U, V, A, T, S, and then he reaches a speed of 56 meters per second, and he starts at rest, he finished at 56, we'll say it's 9.81, T and S we don't know, and my question is, what is the time? How long? Okay, so I shall use V equals U plus AT, I think we'll do it. V equals U plus AT, 56 equals 9.81 T, and that's what you did as well, Amanda, isn't it? So I'll trust that your answer is right.
Right?
What? 56 divided by 9.81 is, what's that, about 5.71 seconds you have in your book. Yeah. Why do you sound surprised?
I'm not sure the answer.
Yeah, this is how to do it. The skydiver opens his parachute and decreases his speed to 1 meter per second over 6 seconds. What was his drag force during those 6 seconds? Okay, so if you look here, here's the skydiver here, and he starts with U equals 56, but now he finishes with V, because he has his parachute open. That's the parachute. His A is different now. His T we know is 6, and the S we don't know. And I want the A firstly. So which formula to use here? What do you think? V squared equals U squared plus no, because we don't have S.
We can
V
we
equals...
can know the distance.
Actually, we could do this one again, couldn't we? V equals U plus AT. 1 equals 56 plus A times 6. So that would be minus 55 over 6 is the A. So the A is, let's say again, minus 55 over 6, which is what you have as well. Although you have the wrong, no, you got the S?
I don't know.
Yeah, I don't know what you should here. But anyways, I'm hoping if you type that in on your calculator correctly, you have this number here. Okay, but that's not quite finished because I want the drag force.
So why that's minus?
It is minus, yeah, I just didn't write in. Okay, so there are 2 forces on this parachute. What's this force called? No, not this one? The red one. Wait. And then this one? This one is called the drag. Yeah? And then when you add them together, so when you do weight minus drag, that equals the total force. Now, which force will be bigger, the weight or the drag?
The way.
Yeah. The drag.
Wait.
Now the drag force will be bigger because if the weight, like I mean, if he's falling down and there's a force pulling him down, well actually,
If the drag is bigger than
No,
the
I
weight,
thi-
they will fly.
yeah, but the drag will be bigger than the weight while he's slowing down, and then afterwards they equal. See, this is, I'll try and draw it here. So if you look, here he is at the beginning, and he has a lot of weight and then no drag. Then when he opens his parachute, at the beginning, he has a little, he has drag here, and this drag here will become very big as the parachute opens. So you might say, wait, hang on, this is bigger than this, so why doesn't he go up? Well, what happens is, because this is bigger than this, because the drag is bigger than the weight, it will slow him down. But then once he slows down to 1 meter per second, then the drag will equal the weight. So will he continue to accelerate? No. What happens if the forces cancel? Terminal, yeah, he just continues at this velocity. But you're right, Amanda, if the drag was bigger than the weight, he would go up. But that's after he slows down. If the drag is still bigger than the weight, he would start to go up. But I think at least during these 6 seconds here, the drag will be bigger than the weight. So this is equal to the force, the total force, which we're thinking is going up. And this will equal ma. Okay, now the weight is mg, the drag we don't know. The m, do we know the m? Oh, rats, I didn't give you his mass, did I? Okay, I'll have to give you a mass now. Let's say he is 60 kilograms. A. So let's see, I have 60 g minus the drag equals 60, oh, and actually I know the A, here it is here, minus 9.16. So 60g plus 9.16 times 60 equals the drag. So I have 60 times 9.81 plus 60 times 9.16, that equals the drag. Okay, so can someone, Yanni?
Yeah.
Can you type that in and tell me what you get? Now the last part here, part C, where's my pen? I don't see it. Part C, I say, will his drag force stay the same?
113.2.
Thank you. 1138.2 newtons. That's his drag force. And my last question here for part 1 is, will this drag force stay the same? And Amanda, I think you know the answer maybe. Will this drag force stay at 1138.2? Will it continue like this, or will it change? What do you think?
I see maybe vehicle.
Yeah. What'll happen is, no, it won't stay the same. No, it will change. And what did you say it will change into? It'll equal what? The drag force will become equal to, what do you think? The weight.
Yeah.
Because you want the parachute drag to cancel the weight, so that he can fall at a steady speed, not go faster, not go slower, constant speed. By the way, what is his weight? His weight is 60g. Yanni, can you type this in? 69.81?
558.6.
558.6. newtons. So if you want to draw the story here, at the beginning he's fallen, and then later he opens his parachute, and the parachute has a lot of drag. But then later, when he slows down, the drag force and the weight, they cancel. So it's only big while it's slowing him down. Yeah? Yeah?
It means that the drop, if the drop is bigger than the weight,
Yeah.
so the speed will become slowly.
Yes, yeah. So the drag is bigger than the weight, so it decelerates, the speed slows down, and then once the speed slows to 1 meter per second, then they become balanced.
So they become balanced.
Yeah.
This one will become fly in the air, but no up and no down.
No, still falling, but at this speed, the speed is not changing. You see, when you drop something, it gets faster and faster.
Yeah.
But in the last picture, he will fall at 1 meter per second.
The same speed.
Same speed for the rest.
Fall down.
Yeah. So he hits the ground at 1 meter per second. Yeah. Now, I know this one was a bit tricky. And yeah, I mean, I don't know what else to say. I know it's tricky, but it looks like some people got some of it at least. Yeah. Okay, we'll do the second one. Can I just highlight something here? So this weight here, I should have really said in the question to include it. Yeah, you know what? No, just forget about this. I don't want to spend too much time on this. Yeah, forget about it. All right, let's have a look at the next one. A bullet is fired upwards at a speed of 300. So it goes straight up, and then comes to rest, and then falls back down. At the beginning, its U is 300. How long until the bullet hits the ground? Okay, so first let's see how long until it gets up here. So U is 300, V is 0, A is minus 9.81, T we don't know, and S we don't know. So let's see what we get. What shall I use? V equals U plus AT again. V equals U plus AT. So, can someone type this in, please? 300 over 9.81, what do you get? You have a calculator, Taken?
30.581.
What is it, Yami?
30.581.
Okay, 30.6 seconds. Now we need to do the part where it's falling down. And I tell you in the second half that the terminal velocity is, what do I say it is? 150. So what will happen is this will fall down, but you know, around about here, it's only going 150 meters per second, and it doesn't get faster. It just continues at this speed for the end. So what I need to do is break this up into two parts. First I should do this part, and then I should do this part. Okay, let's look at the top part first. Let me write here. So what's U for this top part? Let me call it part A and part B. So for part A, what's U? What's U, anybody?
0.
0, yeah, and V? 150, and A is 9.81. Well, if you want, you should really put in minus here and minus here. And I can use V equals U plus AT again, so I get minus 150 equals 0 minus 9.81 T, so then T equals 150 over 9.81. Yemi, would you be so kind? What do I get here? Yeah.
Sorry, what's that?
150 over 9.81. 15.290 seconds. Now, we should also find out what the S is. So, actually, can I borrow the calculator? Might be a bit easier. So, what I'm going to do is go back to the start and calculate the S on the way up. So I'll use S equals U. The T I said was 30.5. U T plus a half A T squared, which is really big. U T then a half A T squared. Yeah, got a huge number. 5.875 meters. I think this is too big. Bullets don't usually go this high. I think I made my bullet go too fast. Okay, so that's this distance here. Now I should find this distance here. So I'll do the same thing. S equals U, which is 0, T, okay, and then a half A, and T squared, which is 15.29. So when I calculate the S here, I get 1147 meters. So now I can know the distance for the last part of the journey. B. The distance is 4587 minus 1147, so that is 3440.
Sorry, how do you get the 1,147?
I just use S equals UT plus a half AT squared. Yeah. It's okay? Yeah. Okay. For this part of the journey, what's the acceleration? 0. Why is that, KJ? Constant speed. So I'll just use my distance, speed, time triangle. Distance, speed, time. And I would like the time. So that's distance divided by speed. So the time is the distance divided by the speed. So that's 22.9 seconds. So finally, the total time is, let's see, 30.5 plus, 15.29 plus 22.9. So I got 68.7 seconds. Okay. Yeah. This one? This one? I used ut plus a half a t squared. So the u is 0, so that's gone. And it's a half a t, which is 15.29. Yep. Yep, it's okay. I can go to the next one? Yep. Three. A 1200 kilogram car will accelerate to a top speed of 160 kilometers an hour over 20 seconds. So it's going at 160 kilometers per hour, and it took it 20 seconds to do this. Oh, and what did I say? 1,200 kilograms. So the mass is 1200 kg. The U is 0. The V will be 44.4 meters per second. The A, I don't know. The T, I do know. The S, I do know. No, I don't know. Okay, I'd like to calculate the A, so what can I use? V equals U plus AT. So that would be 44.4 equals 0 plus A times T. So the A will be 2.22 meters per second squared. Okay, so not quite finished yet, but I have the A, which is important. So this should be okay, yeah? Okay. So at the beginning, there is only one force on the car. We'll call that the driving force. And what happens when the car goes faster and faster? What happens to the car when it goes faster and faster? Not today. What happens?
It's increase
What increases? Something increases.
speed.
Yeah, going faster and faster. But what does it feel? It feels more drag. So at the beginning, there's no drag, but then at the end, there's lots of drag. In fact, at the end, how much drag is there? It must be the same as the driving force. Why is that now, Sophie? You said the same, didn't you? Yeah, why is it must be the same? You're right, so what's the reason? You don't know, that's okay. Does anyone know? Balance the force, but why do you know the force is balanced? Yeah, but why do you know this? Because I said in the question, that's its top speed. 160 kilometers an hour is its maximum speed. So it can't go any faster. So that means the drag force must cancel the drag force. Okay? Now if I look here, if I calculate F equals ma, here I would get, what did I say was 1200? 2,667 newtons. So my question is, this 2267, is that the drive, or the drag, or both, or neither? We think drive?
Drive and drag.
Drive and drag, because they're equal?
You mean the same,
Mm-hmm.
because the same.
Yeah, so maybe. What are ideas? No? It's not either of them. Now, if you look at why that is, that force there is the total force after you cancel out the drag. But you might say, well, how can I do this? Because the drag keeps changing. So what you can do is you can make an average. At the beginning, the drag is 0. At the end, the drag is drag. So on average, it's like a half drag here. That F is the total force, which would be drive minus a half drag. Because we don't use this number, we should use an average because it keeps changing. And you also know that drag equals drive. So you can change this into drag minus a half drag, which equals a half drag. And that's 2667. So in fact, that's only half the answer. I need to multiply this by 2. Okay. Can I go to the next one? I know, these are difficult. I know. Next one. So what you have here is you have one beaker, and it's 1 meter tall, and you have a 10-gram ball, and then it's empty. And then there's another beaker, and it's full of oil, and there's a 10-gram ball dropped in this. And the time here is 10% longer to hit the bottom. So first let's calculate the time. U, 0, V, don't know, A, 9.81, T, don't know, S is 1, and we want the T, so I can't use V equals, I can use, what can I use? S equals? S equals UT plus a half A T squared. Time equals 0.45 seconds. So if this time is 10% longer, what's the time here? Yeah, just add on 10%. You think I did something wrong?
No.
Yeah. You think you have the answer for this time? Be about 0.497 seconds. It's 10% added on, an extra 10%. Now, will this A equal 9.81 or not? What do we think? Is it equal to 9.81 or not?
No.
No, more or less?
More.
Less. It'll go slower. Because there is a force going up here, we'll call it we'll call it drag. Right, so let's calculate the A. What do we know? We know the T, we know the S, we know the U. So what can I use? The same formula? Yes. S equals UT plus a half A T squared. That's gone? So here the A is only 8.10 meters per second squared. So let's calculate the force. What did I say it was? 10 grams? So if I multiply by using my F equals ma, I can get the force of 0.0810 newtons is the force. So what does that equal? Does that equal the weight? Does that equal the drag, or something else? Well, we know it's not the weight. What's the formula for weight? What's the formula for weight?
G.
mg.
So what,
Yep.
what's mass?
10 grams.
Okay.
Yeah. So let me calculate the weight here for you. 10 grams times 9.81. So my 0.0810, is that the drag, or is it something else? This answer here.
Where's the display? Before, I don't know the word.
It's the total, or the net. In other words, this, yeah, as you said, KJ, it's the resultant. That is how much force you have after you put these together. That's the total. It's the total, yeah. This is always the total force. The total, the net. So that 0.081 is actually equal to 0.0981 minus the drag. So then the drag force is equal to 0.0171 newtons. Yeah? You don't look, you look very sad. What made these questions difficult? Was the English? Was it the ideas? What was difficult about these? If you can tell me, maybe I can help, maybe I can make more examples.
English.
English is number one.
And the question.
Yeah.
The
So,
ask is not the normal question.
it's strange, yeah?
Yeah.
Next week, do you want to do more examples of these types of problems? If they're difficult for you, we should do more examples.
Because we can't imagine
It's difficult.
Sure.
Yeah. Okay. All right. We'll do more examples of these next week. In fact, I'll try and find some videos, some animations that maybe can help demonstrate this. You know what I mean? Like, for example, here with the ball, maybe it would be nice to see on an animation the weight, and then there's a little drag. Oh, sorry. And then later there's more drag, and then later there's more drag, and then later the drag and the driving force equal. You know, if I could have like a video maybe, and maybe we need to see more examples, maybe more English. Yeah. I'm trying to help you, so you need to tell me what you need.
So the idea,
Yeah, so what do you need me to do? Do you need more examples? Do you need more notes? Do you need more videos?
maybe
Like
like
more examples of more explanation.
You need more examples. More examples will be good. So, how about next week? Yeah, I don't like using this room. It's too hot.
yeah. But these
It's
are
not
kind of-
comfortable.
For the other examples, can you like explain them more slowly?
Yeah. We'll try and do this. Okay. I think next week, when we're in this room, I think I'll only use the projector for half the class, because the projector's making the room too hot. It's not comfortable. So what I'll do is we'll give you more examples, but I won't record them. I'll just do them on the board, okay? So you need to remember this next week, because if you miss the class, then you miss it. Yeah? But I'll just do them on the board.
On Monday or?
No, it's okay. No, next Friday, when we're in this room.
Oh, okay.
Yeah. Let me just pause this here.